We're videotaping. Ha ha! Well, let's do it. I like to do that before every video just for fun. All right, this is where we were talking about nervous tissue, and we were talking about function. Number one, detect stimuli. You can do this by detecting internal, external stimuli, stuff that your body's doing, or you can actually perceive things from the outside world through your five senses. Now, the five senses, what are they? So we got touch,
Taste.
touch and feel, same thing.
Listen,
Taste,
sight,
smell,
hearing.
hearing, and sight. Those are the five. But if you go to your skin, watch this. Touch is just one of the receptors in your skin. So you actually have five senses, but one of them is multi-sensory. Whoa.
Pain.
Ah, you have receptors for pain. So touch is just the ability of your body to know that something is touching or laying against your skin. Okay? Like when you first put clothes on, do you know the clothes are against you? Of course you do. But because it's non-threatening, you very quickly let all of that go so you can perceive new things. So we got touch, pain, what? Aha. But here's the cool part. You got to do two receptors. One is for hot, the other receptors are for cold. They are separate. And then by interpreting both of them, your brain can determine relative temperature right up to the danger point. But there's one more. And this is the one that people often forget about. Starts with a P. That is not a receptor. No. Okay, when this goes to YouTube, I'm going to look like the worst teacher of all time. What can your skin perceive? Penicillin. No.
Oh, yeah, can you buy a vowel?
How about another consonant?
Yeah, another letter.
An R.
Prince Harry.
All right, I'm off camera. I'm going to put your
Prickly.
hand up.
Prickly.
Put your hand up. Ready?
Prickly.
Pressure.
Pressure.
Aha! He got it. Pressure. Okay, now look. Touch, some people think touch and pressure are the same thing. They're not. Pay attention, guys. Touch is the ability to know something is against your skin, and then you can determine whether or not it's dangerous. But pressure, those receptors are deeper in your skin, because when pressure is applied, your brain automatically detects danger. In fact, even if one of your friends would start squeezing your arm too hard, what would your instinct be?
Punch
To
in the face.
pull away, because that's going to damage underlying structures: bone, nerve, soft tissue, muscle, etc. So you have the five senses, but touch is actually related to skin receptors. So now you can perceive all types of things from the outside world to keep you safe and keep you alive. Now, that's just one function. Two, nervous tissue can also send electrical information. Once it's detected, it can be sent in both directions. Watch. We can send it back to what two organs? Brain
In the rest of your group.
Spinal cord?
and your spinal cord. Because these are the two organs of your nervous system that can do what role or play what role?
Send electron.
Once you detect information and you send it here, these organs can do what?
Perceive.
Oh, come on, I taught this to you yesterday.
Interface.
Good thing we don't tape every lesson. People will be like, why don't those kids know that stuff? That teacher was awesome. He's incredible. I'm just saying that on YouTube so people think it's true.
No, that's not person.
These two can do interpretation, determine a course of action, and then send that action right back out through peripheral nerves, which then stimulate target tissues and cause a what? Starts with an R.
Reaction.
I like it. I was going to say response, but that's good too. Reaction. And you are doing this all day, every day, even while you're asleep. You're still monitoring your internal organs and your systems, and you're on the teeter-totter of what?
Death.
Oh yeah. Maintaining all of this stuff by sending and receiving electrical information. This is what your nervous system does. I'd like to say it's not that complex, but obviously it is. But it only does one thing: send and receive electrical information. Now, it can't be a tissue unless the tissue is made up of what?
Tissue.
Cells.
Cells is correct. Tissue? The tissue is made of tissue.
Kleenex.
We got to do cells. One. There are two groups of cells, but the first group, star smiley face, is overwhelmingly the workhorse and the most common. Does anybody know from the class question? I can jump there now. Class question, here, boom. What name is given to the principal cells, the main cells of the nervous tissue?
Nerve cells.
Well, you can't say nerve cells because that's not scientific. But you're not wrong.
Nervous cells.
Oh, I thought I taught this to you in 8th grade if I had to. Don't you say it, Eli, don't say it. We don't know what a nerve cell is called. I'll give you a clue. It rhymes with moron.
Neuron.
Correct. I knew you'd get it if I said moron, Jonah. That was funny. I don't care who you are. Neuron. Now, these are the cells that can send and receive. That's why they're the principal cells. They do all of the work. They allow your tissues, your brain, your spinal cord all to communicate. They send and receive electrical information. Now, there are a variety of different types of neurons. I will save that for histology when you're all in college and you're juniors and you got to take this class because you're pre-med or pre-something. MC, most common, not Master of Ceremonies. Most common, one of the most common, is called, oops, oh, I got it. Went right out of my head. It's called a motor neuron. A motor neuron. These are the ones that are going to be found in the nerve bands that actually operate muscle tissue and allow you and other structures to what? Move. Very good. You saw me moving. I don't think I was on camera though. There we go. A motor neuron. Now, give yourself space above and below your drawing. I'm going to add labels and other content. Everybody ready?
Yeah.
I would also recommend that you don't make it real small. I'm going to do like half a page.
You think
Okay.
it's not enough space?
That's perfect. Absolutely perfect. Okay, so I'm going to draw this. I'll give you, I don't know, 45 seconds to a minute to draw this. Here we go. Okay? You can start whenever you want. Yes, you can.
Well, it has
And the
a tail.
naysayers already starting.
It has a tail. Yeah.
Okay, now I need a little space right here. Okay, and then there's little circles on the end like this. Like that. Typical motor neuron right
Where
now.
have I seen it
Highly branched.
You've seen this before in 8th grade. I taught it to you and I labeled it when we were doing the diversity of cells.
I
before? I
can
think
see
it
it in
was on
I can see it in
I don't know what Mrs. Verdesky taught, so if you had her, maybe you did not see this, I don't know.
I don't remember.
Probably not me.
I think I thought it was.
I mean, not remembering doesn't guarantee that the teacher didn't teach it. I think it's American high school, let's be honest.
I don't think she's good.
Look at that. Jared whipped that out in about 10 seconds. My man.
I'm a little.
Hayden's
I'm
on
trying to make my little meat.
All right, man.
Yeah, this little orange.
So I need to draw that dotted line.
Yes. That is critically important to the explanation of how they work.
This is the end.
It's really cool. I have another 20 seconds or so. 20 seconds. We should have had Jonah get on stage and do some jokes for us.
That would be very funny.
It would have been.
You just had to cut them off.
Because then we could have stopped it and make screenshots. That funny stuff in this picture. All right, here we go. Labels. These hair-like structures right here, and I know they ran off this screen right there, sorry about that. Those are called dendrites. Their job is to receive electrical information or stimulation from surrounding neurons. So information is coming into this end of the cell. That information is then redirected into this area, which has the overwhelming vast majority of the cytoplasm. That area of the neuron is called the soma. In 8th grade, we also included cell body. So I could use both of them. What's that right there? That's the nucleus. Good. So you know this is a living cell. It's ready to go. Now there is one single extension going away from the soma. That is called the axon. Its job is to send electrical information. So you can see it comes in through the dendrites, redirected by the soma, and then the electrical flow is going to go down the axon. When you get right here, somebody tell me what the axon does.
Branches.
It splits or branches, and then what does it do?
Branches again.
These are called telodendria. They actually named them after tree branches. Ooh, tough one. Telodendria. And then at the very end, we have these little circle thingies. Those are called synaptic end bulbs.
It's not like-
And inside of those bulbs are special chemicals called neurotransmitters. Now, don't do this to your notes. Don't do what I'm about to do. Okay? Electricity comes flowing in, goes down the line, splits, boom, and hits one of those things. That changes the diffusion of that end of the cell, and little chemicals start flowing out, and they migrate across an intentional space. Write the word space. Don't do the electrical flow, because I'm going to add stuff to this drawing to save you time later. That space is called the synapse. Write that down. I'm going back to black. That's called the synapse.
So there's space.
Now,
around-
listen to this because it's not going on the board. Your neurons do not touch each other. There is an intentional space between this neuron and the next one or the next several that are sitting here. And then between them and the next one and the next one and the next one, there's always an intentional what?
Sensory.
There's a gap, there's a space. Here's how electricity flows inside of you. It's electrical here, and then it turns into what kind? Then it's chemical. Those neurotransmitters then initiate another electrical event in the next neuron. So you're going electrical, chemical, electrical, chemical, electrical, chemical, and how fast is this moving?
Super cool.
It's lightning quick. Like by the time I snapped my fingers, all of this was already coordinated by my brain. Wow. I didn't have to think about that. I know how to do it, and I can do it. There's a reason for this. By having an intentional space, this prevents electricity from doing what inside of you?
Electric.
Running away.
Leaving out. Hitting.
Causing problems.
What's pressure?
You're close. Hey, does anybody know what that silver box is in your house in the basement? It's like about this big.
Fuse.
What's that?
Fuse.
Well, they're breaker boxes
Yeah,
now. In the old day, they were fuse boxes when we had Nobbin too. But that's a breaker box. What's that for?
The
Controlling the
electricity.
distribution.
You can turn it on and off which room is having electricity.
Okay, that's technically true. It does give you control over where the electricity is flowing. Let's assume all of the breakers are on and you don't go down there. What's it for? Oh, we're going to learn something about electricity in your house today.
Keep
It
it safe.
closes the circuit.
What's that?
It closes the circuit.
It actually opens it.
Whenever you turn it off.
That's opening the circuit,
Yeah.
right? Let me ask you this. Well, I'm going to give it away if I ask that question.
What are you trying to ask?
That's what I'm working on that question. That's the tough part about trying to get an answer out of kids that don't know the answer.
Well, can you ask
I got to
it
ask the
again?
right question. Give me a second. Flow in this neuron is a one-way street. It's one way. It always goes dendrite, soma, axon, bulb, synapse, restart. Over and over and over. By having the synapse, this prevents electricity from doing what?
Go to the wrong one.
Going the wrong direction. I just had to have the right information. We cannot have electricity going backwards. Now listen. Can you have electricity going backwards in your house? You can. I'll rephrase. Should you have electricity flowing backwards in your house? No. If you get an external power surge, it rushes electricity back through the lines to the breaker box. And what do the breakers do?
Great.
They flip open. What does that prevent?
Electricity for baby.
So you don't burn your house down. Electricity is not allowed to flow backwards. Now, do you have a breaker box inside of you as a human being? Oh no. So there has to be an intentional system to prevent electricity from going this way. So the next neuron only fires when it is told to by these chemicals. So it can never go, so you don't short circuit your own system. Now, could I short circuit your electrical system? Oh yeah. Let me give you a big jolt from the outside. What happens? Boom! It'll shut you off. And maybe, just maybe, you get a reset. Be careful out there. Electricity's sketchy and you can't see it. This is a typical motor neuron. Now there's more. 2. There's another group of cells called neuroglial cells. These are not neurons. Exclamation point. That means they can't do what?
Pass electricity.
They cannot transmit electricity. So you should be thinking, then what do?
Chemicals.
Their job is twofold. They provide support and protection, depending on what type of neuroglial cell it is, sometimes both, and they provide this to neurons. Some of your neurons actually have personal assistants to take care of them. To examine these two things, let's do one example, a very common neuroglial cell called a Schwann cell. I do not make this stuff up. This is not the frozen foods ice cream guy. A Schwann cell. Now these cells are actually found in conjunction or related to motor neurons. What? I'm a genius. They work side by side with motor neurons. What do they generically or generally provide to said motor neuron? Support and protection. Okay? So what I'm going to do is I'm going to put in an extra. You can just add this to your drawing because you didn't do the electrical flow part, right? You didn't do that. I'm just going to draw another one real quick. Not even a complete one. Got it? I just drew a quick one. You don't have to do this. You can add it to yours. Now, your little Schwann cell guy, he's going to be living right about there. That's where he lives. See, he's hanging out with a motor neuron. And then he's going to extend and wrap himself, and I am not teaching this correctly, so whoever's watching this on YouTube, don't beat me up. It's high school. It actually creates something called a myelin sheath, if you've ever heard of that. When these break down, then you get the weird firings in your brain and bad things can happen. Parkinson's and other things. So we got an extra cell with a cell, neuroglial, Schwann cell with a motor neuron. And he's hanging out and wrapping around the axon. By doing that, 3 things are going to be provided. F period. What? Insulation is number 1. My man. Now, period 1 says, oh, does he keep him warm? No. No. That might have been Eli. Not sure. Or Kevin. Could have been Kevin. Could have been. Or it was Wyatt. Wyatt.
Keep the electricity from getting out.
Okay. With a pelvis. Sorry. I wish you guys could see the other kids. It's hilarious. Insulation. I'm not talking about warmth. Let me ask you this. Is there insulation on the wires in your homes? Yeah, it's that like plastic rubberized coating, right? And then each individual wire has its own coating. What does the insulation do? That stops the electricity from exiting sideways, so you get continuous directed flow. It's really important. In fact, it's really important in your house because do you want electricity exiting sideways out of the wires?
Yes.
Yeah, if you want to start a fire in the wall, it's a great idea.
Like that house.
That's why we got rid of knob and tube. It was dangerous. Okay? 2. What else does this little guy, a Schwann cell, provide?
Protection.
Support.
Yes.
Support and protection.
Okay. Watch this. Keeps the axon.
From damage.
I'm getting there. That'll be the protective part.
Moving.
Keeps the axon free of debris. That's actually debris.
Debris.
It's debris. Listen, do you want garbage around this very thin extension from a microscopic cell? No, it could cause damage, cut it, etc. So it keeps it free of debris just by wrapping around it. So we get multi-tiered protection, right? 3, these cells also provide nutrition. I like to think that neurons are so busy doing what they do, they don't even have the time to take a break and eat lunch. So they have a personal assistant that, one, not only provides the food, but knows when to provide it. It's like a perpetual, I know you need a snack kind of helper. That's pretty cool. So you have neurons to do the work, neuroglial cells to provide what? Support and there's one example. Any questions? Nothing? Wow, I am that good. The end.
Thank God.
Thank God, thank me. I'm the one that ended it. Here we go, homework. Homework. We're gonna do period 1, 1 of the extra points. 25 review questions. Whoops, I am not writing very well right now. Let me try that again. Try that again. Review questions and answers. You guys know all the rules to this assignment. For the remainder of the period, you can either work on this, or you can do this at home and do bones right now. It is all bones until next Tuesday. Let's go. See you next time.